why we're here. We're going to spend an entire semester learning about this. So it helps if we kind of start with the groundwork about what statistics is all about. What are some common words or terminologies that would come up with when one studies statistics? So let's start with the word statistics itself. Statistics is actually a science, and it's a science of looking at data. What kinds of things can numbers tell us? So anytime we talk about how to collect it, how to analyze it, or what kinds of things data can actually mean, that falls under the umbrella of statistics. Okay, so let's do a little thought experiment, and as we're doing this, we'll kind of define some other terms. A lot of students just recently graduated from high school, so suppose I want to know, are things better? Did they actually improve? I've got numbers from 10 years ago. I got numbers I would like to know, are they better? So what would one do to answer that question? Well, one sense is we would want to collect information about everybody. And when we do that, what do we mean by everybody? Well, in statistics, we refer to that as the population. So the population is the entire collection of individuals or group or objects in which we want to know information about. Um, Now, in the United States, every 10 years, we actually collect information about the entire group, and that's called a census. Kind of interesting, and we'll look at later what some of the characteristics of that. Okay, but going back to our little question here, so suppose I want to know if things have gotten better. Uh, we could go out and ask everybody, but is that really practical? And the answer is probably not. So if I don't talk to everybody, I got to talk to some people, and that some people is we call a sample. Sample is a subset of the population that is picked in some clearly defined manner, and we will spend a lot of time talking about what we mean by that clearly defined manner. Now, if I was to collect a sample of all the high school graduates, what would it look like? What kind of things would I expect to see? Would I see numbers? Would I see words? Would I ask someone what kind of grades did you make in high school, and they say turkey? I mean, what would I expect to see? And so, in general, I'd expect to see a list of GPAs. So I'd expect to see some sort of numbers. So it kind of helps to know what the sample is supposed to tell us. So I want to know how the high school grad students are doing. I collect the sample data. What does one do with it? Well, that's where descriptive statistics come in. Descriptive statistics is the rules and regulations and guidelines that cover how we organize and summarize the data. Now, this could be things like a graph, could look at some numerical summary numbers, things like ranges. We could look at the highs and lows. We could look at the average. What would the average look like for something like this? Um, so keep it with our thought experiment going. Once we've got our sample data, and once we've drawn pictures and looked at summary data, what does one do with it? Well, that's called inferential statistics. And in inferential statistics, we make generalizations from the sample to the population. We take a look at what the samples told us, and there's certain rules that govern how one can spread that out to the population. So if, for example, my average GPA for my sample was 3.0, what does that suggest about the entire nation? Well, if I've followed my data collection rules appropriately, then I would expect that the national average should be pretty close to 3.0. I wouldn't expect it to be too far off. Um, does that mean that someone can claim that the average GPA for a particular school district is 3.0? Well, we can't necessarily say that, but that does give us some sort of indication. All right, now when we look at the samples in the population and the things that we are collecting, well, let's talk about the things we're collecting. In just like a normal math course, we've got variables in our class. Variables are things that can change from one situation to a next, but it's not the same as solving for x. So, for example, if I look at the number of wrecks in a particular intersection each week, is that a variable thing? And the answer should be yes. I hope it's not a constant. I hope that just because you had 3 accidents last week out near your house that you don't expect to see 3 every week. Although when there are constants like that, that does make us kind of wonder if there's something else going on. Okay, data refer to the actual observation on a single or on two or more variables. So when we look at these things that we're collecting, the thing that we collect is the data on it, and the data itself can be in several different flavors. So a little thought experiment here. Let's do some statistics. We're looking at two different graphical representations. So these are descriptive statistics over two different groups. See, the two histograms display the heights of gymnasts and female basketball players, which is which and why. Okay, so one group are a group of gymnasts, and one group are a group of female basketball players. Take a second and think about which one is which, and then why do you think it is? Okay. I'm going to tell you that it's safe to say that figure A is most likely the basketball players. And the assumption that I'm making is that basketball players typically are taller than gymnasts. Now, that's using statistics. That's using information about the two groups that I have experience with and then generalizing it to this particular data set that I'm staring at. Now, let's do some inferential statistics. Let's say we find a pair of size 6 shoes in the locker room. Who do I go to first and why? Now, I find this rather amusing. Size 6 is actually very small. So if I find a pair of small shoes, I typically would assume that the gymnast would be more likely candidate, so I'd go there first. Now, suppose a tall woman, 5'11", comes in and says she's looking for her sister who's practicing in the gym somewhere. Where do we send her? Again, we're making an assumption. I assume if the sister is tall, then the student has to be tall. I'm using inferential statistics to take some data and make some generalizations about it. So I would send the taller woman to the basketball court and hope it worked out. Now, is that always true? No, but that's what statistics is about: is taking information and making conclusions about it. Okay. Now, under the umbrella of statistics, we actually have a process in place about what one should do. So we're going to go through the 4 steps to how one should properly do statistics here. Now, one of the interesting things about stats is we love to ask questions, and that's actually the first step. One is to identify a research objective. So in other words, come up with a good question. So we have this sort of thought experiment. It's not really a thought experiment. There's actual data that go with this, but we have a group of males who've been accused of hurting their partners, and we have 2 suggestions for how to fix this problem. We think, not we think, the study was done is they did 2 things. They put a group of males in a sort of education program, sort of let's teach you how it makes the woman feel. And then the other group was assigned community service. Let's just make you collect trash for 40 hours. Okay, and I want to know which program is better and if it matters. That's kind of the same question. Does it make a difference whether we train them or educate them, or whether we just make them clean up trash? So after we ask the question, we actually go out and collect data about it. So that's step 2, is collect information needed to answer the question. So the researchers divided the men up into two groups, and group 1 was given the 40-hour education program, and group 2 was given the 40 hours of community service. 6 months later, they then looked at the two different groups to see, is there a difference in their behavior? Okay. Now, why 6 months? And the answer is, I don't know. Sounded good. That's just in this particular study. That's why they picked. They could come back a year later, and a lot of times they actually will. They'll look at like cancer studies. They'll look at drug treatment programs, and they'll look at what happened 6 months later, 6 years later, 60 years later. Is there a significant difference in the survival rate of various treatments? So that's stuff that's ongoing all the time. So once we've collected the data, what do? We want to organize it in some way, shape, or form. And that's that going back to that graphical information or that numerical summary information, which we'll learn more about. In this particular program, they discovered that, and they're just kind of clarify some of the terminology here. The experimental group was the education group. They're saying we did something different. Normally, we make them pick up trash for 40 hours and sort of punish them. The experimental group is we wanted to educate them and see if there was a change in their behavior based on the education. So after 6 months, 21% of the males in the control group, this is the group that picked up the trash, had still had an incident of not learning anything. There's still abuse there. Whereas 10% of the education group made a difference. In the other group where they educated them, only 10% had further incidents of battering. Okay, so collect the data, organize it, summarize it, and then step 4 is to draw conclusions. So once we've looked at what the data can tell us, then we try to look at some sort of interesting observation we make. So if we take the results from this particular survey and we look at whether does it matter, and the answer is yes. Of the 376 males that were in this particular study, they found it was better to educate them than it was to just make them pick up garbage. That there was a huge difference in changing one's behavior once they understood what it is that they were doing and how it made their partner feel. Did it fix everybody? No, but there you go. All right, so let's talk about types of variables. As we're collecting the data, we're going to see that there's different types of ways to describe information. The first type is something called categorical variables, or qualitative, refers to the quality of an object. These are word phrases. Things like, what is your favorite color? Would be a categorical variable. How would you rate the service? Good, very good, not very good. Those are categorical variables. After categorical, we have numerical or quantitative. Quantitative refers to quantity or number of an object. These are things that would make sense to average together. So if I take two ages and I average them up, I get an average age. That makes sense. If I take a zip code, zip codes are made up of numbers, but if I take two people's zip codes and average them up, I'm not guaranteed to even come up with a real zip code anyways. So just because you see numbers, just be careful of that. Now, underneath numerical variables, we have two further types, discrete and continuous. Discrete refers to a listable set of numbers, usually a count. Number of children, for example, is a discrete variable. I would be kind of weirded out if somebody said, yeah, I've got 2.7 children. 0.7 actually doesn't count. It doesn't count till it's there. That would be discrete, where there's only a specific whole number of types. One, not exception to this, but one interesting thing to think about is money. If I have $1.75, that 0.75 makes sense. However, I can't have 0.756. That 6 at the end, we don't have that part of money, so it wouldn't make sense in that sense. Okay, continuous is data that can be taken along. So in other words, the in-betweens make sense too. It's not just the whole number counts that matter. but the in between. So time is a good example of a continuous variable. How long it take to get there? Well, how accurate do you want me to be? Olympics, they typically take those things out to the 10th, 100th, or 1,000th of a second, just to even measure who's top dog in a particular sport. So that would be an example of continuous. Okay, and then the number of variables that we're collecting actually has a name. Univariate, bivariate, and multivariate. Univariate simply means that when I collected the data, I only looked at one characteristic of the data. Average GPA of students, by the way, would be a univariate response. Bivariate means that I collected two specific characteristics. So let's say I wanted to know what the average GPA was and the average age. That would be a bivariate data. Multivariate, we will talk a little bit about, but multivariate simply means there's more than two characteristics that we're measuring. Okay. Uh, so let's go through a couple of sample examples of this. Identify the following as categorical, numerical, discrete, continuous, blah blah blah. So the appraised values of homes in Houston, I would expect that to be a numerical response, and I would expect it to be discrete. Remember, money is discrete. It's okay for it to cost $100,000 and 27 cents. That 0.27 is discrete because we stop after the 7. We wouldn't keep the decimal going. Color of cars in a faculty lot or teacher's lot, that would be categorical. Number of calculators owned by students, again, can they have part of a calculator, or does it all have to be whole number? And that would be discrete numerical. And zip code of an individual, I kind of talked about this earlier. Even though the zip code is made up of numbers, it wouldn't make sense to average them. So that would be a categorical on that. And the amount of time it takes students to drive to school. The length of time, how accurate do we want to be with that? Even though I could measure it out to the minute or the second, I could keep going with my decimal accuracy if I wanted to. And so that would be an example of a continuous numerical. As well as the type of variable that we're measuring, we actually have a level of measurement. How far, when we get the data, what can one do with it? So these, I guess, go in order of progressive complexity. We'll go with that. So we start off with the nominal level. Nominal level is when I get a variable and it's a name, a label, or a category. But the key difference here is the way that the naming scheme that I give it does not allow me to arrange it in any particular rank or order. So if I ask the class what their favorite colors are, there's no reason why red is more important than blue, which is more important than yellow. Colors would be a nominal level of measurement. I couldn't rank them at all. Now, if we go one more level and I say that I can rank them, now we're looking at an ordinal level of measurement. So it has all the properties of nominal, so we have it some sort of name that we can give it, but when I give it a name, I can rank them. Ordinal level, in math we call it ordinal numbers, would be first, second, third, fourth. If I can give something a by its meaning in a rank, that would be ordinal. Okay, interval level. Okay, so now we're looking at all the properties of ordinal, so we can rank it. But now the particular number, the particular data has as meaning with context to others. Not only can I rank them, but I can look at the size of them. Two of this is more important than one of this. 10 of this is more important than 7 of this. Um, we call that interval measurement. So let me kind of read this out, and we're going to look at some examples at the end, hopefully to clarify this out. A variable is at the interval level if its properties, ordinal, are there, and the differences in the values of the variable have meaning. Okay, so not only can I rank them, but the fact that one is different than the other matters, that there's 2 of this versus 3 of this. The value of 0, and this is a key difference in the interval, does not mean the absence of quantity. So the fact that there's 0 trucks for an interval measurement doesn't mean that there are no trucks there. That 0 doesn't matter. So when 0 doesn't matter, we call that interval. But in the same sense, arithmetic operations can be done. So I can add and subtract these variables together. And when I add or subtract or average them out, that has meaning for us. Okay, that's called interval level. So the key difference here is 0 has no significance in the interval level, whereas numerical operations can be done to have some sort of importance of the data. And the last one is called the ratio level. Okay, ratio level is has all the characteristics of interval, except, and that's what this middle sentence here says, value of 0 at the ratio level means the absence of a quantity. So in other words, 0 matters. If there's 0 trucks, that means there's no trucks at all in the data. And then we can arithmetic operations, so we can multiply, we can add, subtract. I'm sorry, we're adding on top of multiplication, division can now be performed, as well as adding, subtracting. Okay, so let me kind of make sure we got this before we look at the example. We've got, I'm going to go back to the beginning here. So these are all ranked in level of complexity. Nominal means I give it a name, but I can't rank it. Ordinal means I give it a name and I can rank it, but the particular values are not numerical enough that I could, or not numerical enough, they're not numerical that I can add them or subtract them and have any meaning. Interval means that I can give it a name, rank it, and now adding and subtracting has value, but 0 does not. And then ratio means I have a name, I can put it in order, that's what ordinal means. I can add and subtract, and this time 0 does matter, and then I can add on top that I can multiply and divide, and that has some sort of meaning. Okay, so we're going to kind of use that analysis to answer the following questions. Again, with statistics, we like to look at actual data here. So they did a study on school lunch and the impact of vending machine and policies about food consumption. There's a whole bunch of things we could open up with this, but we're just going to talk about vocab here. All right, so determine the level of measurement of the following: number of snacks and soft drink vending machines in the school. Okay, so think about which of the 4 words is appropriate, and the answer is ratio. Okay, so let's kind of think about this for a second. Ratio means that essentially 0 has meaning. If I say that there were 0 soft drinks sold on Tuesday, does that tell me something interesting? Or does it tell me something? It means, yeah, nobody bought soda on Tuesday. Okay, part B, whether or not the school has closed lunch policy during lunch. So think about what that would be. And that is nominal. Okay, the answer is yes or no. Are you closed during lunch or not? Yes or no. And there's no reason why yes is ranked more important than no, so that would be a nominal measurement. Class rank, freshman, sophomore, junior, senior. Okay, so think about which word would be the most appropriate there. And the ordinal. Okay, so not only can I give it a name, which is nominal, but now I can rank them. I know that, you know, seniors different than juniors, different than sophomore, different than freshmen. I can rank them. But notice the word sophomore, junior, senior 0 doesn't have any significance here. 0, I can't add or subtract freshman plus sophomore equals junior. No, that doesn't make any sense. So I can't go up to the next word, which was interval. And then the last one, number of days per week a student eats lunch. Okay, so let's think about, are we looking at numbers? So yeah, we're looking at some sort of either interval um, or ratio. Does 0 matter? If I have 0, if a student eats 0 school lunches, does that have any significance as far as the data is concerned? And the answer is yes. So this would be another example of ratio.